Hello, my name is Jonathan Day. I'm a student at Ferris State University, and this is an introductory video on database design for ISIN 325, database security. So, first things first, what is a database even? To give it a gross oversimplification, a database is simply an organized collection of related data. And in this course, we're going to primarily work with relational databases, which are databases defined by relationships in the data. Which, makes sense. Relational databases, defined by relationships in the data. It's a good name. And relational databases are structured similarly to an Excel spreadsheet using tables, lots and lots of tables. A complex database is going to use hundreds or even, thousands of tables that are all linked together using the, magic of primary and foreign keys. And those are the glue that, links these relationships together between, multiple tables within a single database. And this primary and foreign key of relational databases allows for fast queries and large data sets. That was a vast improvement over the hierarchical databases of the past, where like a query would actually have to go through an entire hierarchy to actually return the results of a database query. Database normalization. What is that? It is how data is organized within a database, or probably more accurately, it's how data should be organized within a database. And normalization of a database, you want to adhere to normal forms. Normal forms are rules. They are the rules that are the essentials of good database design. The first normal form or first rule: if there are no repeating groups and there are atomic columns. Now, if I say groups, if I say columns, if I say attribute, just know that I'm talking about the same thing. And atomic means that columns are broken down to an irreducible form. So, for example, let's say we have a table for students, and we have a column in that table that is student name. And how do I input me into student name? Do I put John Day, Jonathan C. Day, Jonathan Charles Day, Jonathan Day, Day, comma, Jonathan, Day, comma, Jonathan, space, C period, Day, comma, Jonathan, comma, C. I might be in the same table a dozen different times with, a unique identifier that's showing me as a bunch of different students, though I'm just one student. If we make atomic columns, we would have something like first name, last name, middle initial, and that way you can't reduce those down any further than that. You can't reduce first name down to something smaller, and that's what's meant by atomic. A second normal form is that columns must be dependent on the primary key. So let's take that student table I was just talking about and say we have the last name and first name, which is the atomic, and that's good, and we might have address, city, state, and zip code on there, and that makes sense because that's all dependent on the primary key. But then we have another column for vegetables. And you're like, what? Vegetables? That's not dependent on the student ID primary key. What on earth is that doing there? That's a good question. It violates the second normal form. No vegetables in the student table. Third normal form is no redundant data. If you aren't careful, you might end up with the same data in a dozen or more different tables across a database, because it seems like it kind of makes sense for it to be here. Like I could see how it would end up here, and that's why we need to be careful about where we put data and to make sure that we aren't duplicating in places, and that where we are putting data is the most appropriate place for it to be. And that means, where is it the most dependent on the primary key? Where is it, most adhering to, those first and second normal forms? So you could have as many foreign keys, linking tables together as you wanted, and those are not redundant. So if I have, student ID, which is going to be my foreign key linking, all these different tables together that aren't the student table, I could have that in a million different tables, and it's not going to be redundant. How relational databases work is linking tables together using primary keys and foreign keys. And there are more normal forms that exist, but they are not within the scope of this class, and so they're not covered in this video. Bad database design. So right here we have an example of three tables that are implementing various degrees of normal form violation. And let's see here. Can you spot them? And I'll give you 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. I don't know. Let's move on. So bad design and how to fix it. So we have that student table from the previous slide, And we see we had student name, which we covered in the example of normal forms. And student name violates the first normal form because it's not atomic. I could write a student name, a dozen different ways and have a dozen different ways of referring to the same student. We got to make it atomic. And then we have kind of the opposite problem where we have repeating groups with phone number 1 and phone number 2. All right, there we separated things, but we didn't make them specific enough to truly be atomic either. With phone number 1 and phone number 2, I could have, work phones, cell phones, and home phones all appearing as a phone number 1 depending on, which person it was for. And then on phone number 2, I could have the same thing. I could have work phones in there, I could have home phones in there, I could have cell phones in there, and I would have no way of knowing, which number was which. But in the fixed versions, we see we have atomic naming. We have first name and last name instead of student name. We have home phone and cell phone instead of phone number 1 and phone number 2. A more bad design violating the second normal form. So here we have the student table again, and we have dorm list there, and dorm list is not dependent on the primary key. I mean, you could see how, it might end up there. I mean, you have, students go to college, dorm list. I mean, dorms are in college, so it seems like maybe there's a relation there, but it's not dependent on the primary key of student ID. For that reason, it does not really belong in that table. How you fix that is, you can see that we just deleted it in one example there, so there's just no dorm list column. And then we also did an alternative where, let's say we actually have a dorm table, and the dorm table uses dorm ID as its primary key. And we could actually add dorm ID as a foreign key to the student table, and that way I'm linking those tables together so that we could associate students with dorms from the dorm table. And bad design for the third normal form. So here we have just redundant data. We have degree type, which is appearing in the table for a major and in the table for course. And so the answer to this is really to think about, which table is it more important for degree type to be in? Which table is degree type best dependent on the primary key? And the answer is clearly the major ID is the primary key that should be associated with the degree type column. And so it's fixed by just removing it from the course table and keeping it in the major table. And so here's just a look back at the bad design that we originally had, and the unatomic names, the multiple groups there, the redundant data, the non-dependent group, and here we have the better database design. The groups are atomic and they don't repeat. All groups in the table are dependent on that table's primary key, and there is no redundant data. Look how much nicer that looks. And then here we have the student database design, which is just the database that we're actually going to be building in SQL Server next week. So I'll start off with the legend we have there in the top. So table name in the light blue, the primary key followed by its data type in the darker blue, followed by an attribute name with its data type below that, and then foreign key, which I just slightly differentiated from attribute by putting it in brackets, also followed by the data type. So starting left to right, we have the degree table, which uses degree type as its primary key, and integer as the data type for that primary key. So the way that would work is I have a degree, type primary key is an integer, so it's going to increment, 1 to 2 to 3 to 4 to 5 each time I add a new row to the degree name column. So degree name is going to be like Associate of Arts, Bachelor of Science, master's degree. So any degree that we're going to actually add to the degree list is going to then increment 1, 2, 3, 4, 5 as the primary key. And the degree names themselves are using the variable character data type, or varchar. And in parentheses there, I have varchar 30, and that is signifying that in Microsoft SQL Server that I can have up to 30 numbers, letters, symbols for any degree name. I based the 30 limit off of, I think the maximum degree name was 26 on the actual Excel table that accompanied this assignment. Same with, with major. I did that table with an integer as its primary key data type. Major ID is the primary key. Varchars for the major name and major description. Major name, I think the longest one in the Excel tables that were sent was like 36, so I made it a varchar of 40. The major description, I decided to give it a limit of 280 characters. I figured I'd give it a tweet's worth. There was no description that was actually that long or close to that long on the table, but I just wanted to make a decision with something. And then we can see the degree type is actually a foreign key that is linking the major table to the degree table. And so that way you're able to actually, associate those two tables together. So, you have a, major in, information security and intelligence. Well, what degree is that part of? Well, it is part of, the Bachelor of Science. Then you have a special table below the major table. You have student major, and that is actually a composite or compound table. And that is linking the student table and the major table in a many-to-many bridge. And so what essentially that table is serving to do is make it so that you could have, many students in, many majors, many students in one major, many majors with, one student. You might have a double major in this. And so that way you're actually to do these major to major differentiations between the two tables that you wouldn't be able to do without having that compound table, kind of as a helper table. And then the same thing is done with the student course composite or compound table, which is linking the student table and the course table in a many-to-many bridge. And then you have the course table, which is linked to the professor table. You see that professor ID is the foreign key that's used there. It's the same as you see the degree type as the foreign key for the major table. And this is how our database is going to be structured. And notice how that there's, going to be atomic columns. So last name and first name, we're not using professor name. We don't have any redundant data. There isn't a column that is used in, one of the tables that's also used in another table. And we also don't have non-dependent columns. We don't have, column or attribute that is not associated with the primary key for that table. And so this is the student database design that, was given to us that I look forward to building next week. Thank you. I hope you enjoyed the video.